Okay, welcome everyone to ISTQB training session 12. So far we have covered 3 modules, and today we are starting the 4th one, test technique. So this is basically which we covered last time as well, but as I already mentioned that I am repeating session 12 because there were lots of questions on it, and which made me realize that maybe the concept is not very clear yet. So I wanted to make sure that everyone understand it better, so I am repeating it today. Okay, so in test techniques, first of all, we will go through the categories of test techniques. And in that, first of all, we'll see that what's the purpose of using test techniques. Test techniques basically helps us in identifying test conditions, test cases, and test data. Also, there are some factors which helps us to identify that which test technique we should be applying. And these are not the entire list of factors, only few of them, and we'll just go through the list. So the first one is component and system complexity. Based on how complex a system or a component is, we might have need to choose one test technique over the other. Second, regulatory standards. Third, customer or contractual requirements. There might be some certain requirements in the contract which demands the use of any specific test technique. Number 4, risk levels and types. When we identify and we evaluate the risk of a project, based on that, we can choose that which test technique applies to that project in a better way. Number 5, available documentation. For any project, what's the level of documentation available plays a very important role in choosing the test technique. Number 6, testers' knowledge and skills. How experienced a tester is in that specific domain in which the project is. Number 7, available tools. 8, time and budget. That what are the time constraints, how much budget we have, based on that, how much time and budget, which test technique will give us the maximum coverage, maybe in less time. Number 9, SDLC model. Which SDLC model we are using, and based on that, which test technique would be working better. 10, types of defects expected in a component or system. Okay, so these are all the factors. So test techniques are classified broadly as black box, white box, and experience-based. And today we will start working on the black box one. So the black box one is also called as behavioral or behavior-based techniques. It's based on analysis of appropriate test bases. It's applicable to both functional and non-functional testing, and it concentrates on inputs and outputs of the test object. Okay, so black box, the system is like a black box, means like we can't see anything what's going on inside the system. So we have a set of inputs and then we have the outputs. So that's all what we can see in black box testing. So there are some more common characteristics of black box. In this case, the test bases are software requirements, specifications, user stories, and use cases. So test conditions, test cases, and test data are derived from these test bases. Number 2 is test cases may be used to detect gaps between the requirements and the implementation of the requirements, as well as deviations from the requirements. So over here we are talking about the traceability between the test bases and the test cases. Number 3, coverage is measured based on the items tested in the test bases and the technique applied to the test bases. So further, when we will go through the test techniques of black box, then we will also see that how the coverage is measured. Okay, if we have to go further into detail of like what are the description of test techniques, then we have this standard which have more details in it. This is known as ISO, IEC, IEEE 291194. So just like we did one for the reviews in the last session, this is for the test techniques. So you just have to memorize the number of this one, and that should be sufficient. Talking about the test techniques, black box test techniques, we have equivalence partitioning, we have boundary value analysis, decision table testing, state transition testing, and use case testing. And today we will cover the first two, equivalence partitioning and boundary value analysis. Okay, so equivalence partitioning. To understand what is equivalence partitioning and why we even need to apply this technique, let's go through this example. So this is a job seekers allowance form. So whoever is unemployed for a certain period, they need to apply for a job seekers allowance. And for that, let's say this is the form. And this has certain fields like first name, last name, age, address. So over here, we have to test this job seekers form. So regardless of what kind of testing we are doing, just think of that what will be our approach to test this form. Okay, if we just think high level about our test cases, we will do a few combinations of first name, last name, age, address, right? So we will have our test cases with certain test data, and that should be sufficient. Now coming to this field, age, it says that the age range which is eligible is 18 to 65. Okay, so 18 to 65, if we think about all the possible combinations, then how many combinations we have? If we just talk about the positive combinations from 18 to 65, we have around 48 combinations. And these are only positive ones. Then if we talk about the negative scenarios as well, negative input data for this, then 1 to 17, 17 combinations, and then 66 to 100, 35 combinations. And over here also, we don't know whether we should do 100 plus, because that will even increase the input values more. And the same over here, do we need to go below 1, like 0, minus values? So they are like quite a lot combinations. And let's say if we have to test it thoroughly, then we have to use all these combinations, which means that how many times we have to run the same test case with different values, maybe like 100 plus times. Okay, so this is one option. And the second option is we just randomly pick a couple of values and test using that. By doing this, we can reduce the time and the number of test cases, but what's the problem? That we can't assure that we are covering maximum scenarios, maximum tests. And remember, the best approach is to create minimum test cases with maximum test coverage. That's where the role of tester comes in, that what is the approach, what's the test technique a tester is applying. Any tester can write test cases, but only a good tester can write efficient test cases, and that's what we are trying to achieve. Okay, and this is the problem which equivalence partitioning solves. So it should be applied whenever we have a large set of input combinations. So I also had one question where someone asked me that do we need to apply equivalence partitioning technique everywhere whenever we are testing? So the answer is no. So you have to see that whether you have any input value where the range is huge. If you have a large set of inputs, lots of combinations, that would be a good candidate for equivalence partitioning. Okay, so now we have covered that why we use equivalence partitioning, and now let's see that how we apply this technique. So we'll take the same example. And what we do in equivalence partitioning, we divide the input values in sets of partitions, as the name suggests like groups. And these partitions are also known as equivalence classes. And it can be done for both valid and for invalid data, because as we just think about any other testing technique, we always first go for the positive scenarios, and then we also take account of the negative scenarios as well. So this one is also no different. It's the same. Equivalence partitioning is the same, that we first categorizes the valid and invalid groups, and then we have different values from each group. So so we divide the input values in sets of partitions or equivalence classes. And over here, the valid data are the values which are accepted, in this case, between 18 and 65. And the invalid would be which should be rejected by the system or by that field. Okay. And what we do, we test only one value from each group, and we assume that if it works or doesn't work, the rest of the values in that group will behave in the same way. So if one value which we have taken from a group, if it's working, then we expect that the rest of the values in that group will work, and vice versa. So in this example, we can take our test conditions as age 14 from this group, 20 from this group, and 68 from this group. So we are taking one value from each partition, which will be sufficient to cover the entire group. So I hope this one is clear. Coming to the next one is any partition can be divided into sub-partitions if required. Okay, so what are sub-partitions? Let's see over here. So we have the same example, but over here the valid data is also further divided into 18 to 40, 41 to 65. And why is that? Let's say that we have a further requirement for age field, that if the age is between 18 to 40, then we have a separate, the next page would be different for age range between 18 to 40, and from 41 to 65, then we have a age separate form. So what we are doing, we are further dividing it, and now instead of taking one value from this entire valid group, we will take one value each from this subgroup, sub-partition. So from here we can take 30, from here we can take 45, and this is how we do sub-partitions. Okay, going back to this slide. The second one was each value must belong to only one equivalence partition. So from each partition, whether it's one partition or sub-partitions, we are taking only one value from each partition. Then, when invalid equivalence partitions are used in test cases, they should be tested individually, that is, not combined with other invalid equivalence partitions, to ensure that failures are not masked. Okay, what does that mean? That, for example, as we can see that the age fields accepts a double-digit number. So let's say if we insert our input as -101, we will get an error. That's expected, and that's the right behavior. But we don't know that the error is because of the 3 digits which we inserted, or is it because of the negative value, right? So if several failures occur at the same time, but only one is visible, then the other failures can be undetected, and maybe later on it can cause an error in our system. So for invalid partitions, testing should never be combined with negative inputs or with other partitions. They should be handled separately. Okay, so the next point over here is to achieve 100% coverage with this technique, test cases must cover all identified partitions, including invalid partitions, by using a minimum of one value for each partition. So our aim for testing is maximum test coverage. And over here it says to achieve 100% coverage, we should be taking all the equivalence partitions classes in account. So if we have 3 equivalence classes, then we need to take one value from each partition. We just can't leave one class and just take one value from these 2 classes. That will not work. How to measure the coverage in terms of percentage? We use this formula: number of equivalence partitions tested by at least one value divided by total number of identified equivalence partitions. So this can give us the coverage in terms of percentage. So let's say that if we have 3 equivalence classes, but we are only taking data from these 2, then it will not give us 100% coverage. So we will not get 100% over here. The next one is equivalence partitioning is applicable at all test levels. So all the test levels which we earlier covered, component, integration, system, acceptance, we can use this technique of equivalence partitioning in all test levels. Okay, so now we know that what is equivalence partitioning, how we can apply it, and what are the benefits of it. But we also have a limitation as well. And what's the limitation? That because it's a black box testing, we don't know that how the code will be written. So we don't have insight of this code. We don't have access to this code in black box testing. But let's say if we go behind the scenes and see this code, what's the problem in this code? The code says if age is between 18 to 65, greater than 18 and less than 65, then user can proceed with the application. While the actual requirement says the valid range is between 18 to 65, which means that over here it's not covering 18 and 65. So let's say that if a user selects 18 from here, which falls in the valid range, then according to the code, we'll receive an error, right? But because we don't know that that's the problem in the code, we might not select 18 or 65, because in equivalence partitioning, we can just select any one random value which falls in that range. So over here, this means that in equivalence partitioning, if the boundaries are not covered properly, then we might have an issue. And so we can say that equivalence partitioning provides a good test coverage, but doesn't cover all possible combinations. And this is the gap which boundary value analysis technique fills in. So let's see the next one. So boundary value analysis is an extension to equivalence partitioning. It's also known as BVA. So in any question, if only BVA is written, then it means boundary value analysis. So as we already said that it's an extension. Sorry. It's an extension of equivalence partitioning, but can only be can only be used when the partition is ordered, consisting of numeric or sequential data. Okay, so why we are saying that? Because if the data is not in a specific order, then we can't apply proper partitions, and then we can't identify the boundaries of that value, that data. The same goes for numeric or a sequential data. So we do have some conditions, and based on that only we can apply boundary value analysis. There are 2 ways in which we can use boundary value analysis: 2 boundary values and 3 boundary values. Okay, boundary value analysis can be applied at all test levels, just like equivalence partitioning. This technique is generally used to test requirements that call for a range of numbers, including dates and times. So as we already said, that it has to be either numeric or in a sequence. So how we can measure the coverage for a specific partition is the number of boundary values tested divided by total number of identified boundary test values. Okay, now let's see two boundary values, how to calculate that. So we have the same example and I've taken out the values which we selected for equivalence partitioning. Over here, now if we just take this valid range, which we have 18 to 65, and if we go through the boundaries, so 18 and 65 are the boundaries itself. So in two boundary values, first of all, we will take the boundary values, which is 18 and 65. Then we will go a step ahead and we will take each value which is outside of the boundary. So in this case, boundary -1 and boundary +1 in this case, because first we are taking the boundaries and then we are taking one value, the value which is the next value outside that boundary. So in this case, it will be 17 and 66 in this case. So we are taking two boundary values on each side, 17 and 18 over here, and 65 and 66 over here. So I hope this concept is clear. And if you have any question at any time, please just ask in the Q&A section. The next one is three boundary values. Okay, so in three boundary values, what we are doing, like two boundary value, we are still doing the boundary value and the immediate value, which is outside that boundary, but we are also taking the third one as well, which is immediately inside that boundary, in this case, which is 19, and this one is 64. So we are taking three boundary values on each side of the boundary of the valid range. In this case, it's 17, 18, and 19. So boundary, boundary -1, boundary +1. The same goes over here, 64, 65, 66. So we are taking the boundary value, then -1 and +1. If there is any question on this part, then please let me know. Otherwise, we can proceed further. Okay, so we have now gone through the two boundary values and the three boundary values as well. So now if you see the three boundary values, if you also note that it also covers the possible values of equivalence partitioning as well. Because what equivalence partitioning is, that we are taking one value from each group. So if we are seeing this one, then it's covering actually two values from this group, which is a part of equivalence partitioning, and from invalid as well, it's taking one. Over here also from invalid, it's taking one. So the question is that if it covered the possible values of equivalence partitioning as well, then why do we need equivalence partitioning as a separate technique? Why don't we just say that equivalence partitioning is not beneficial and boundary value analysis can just replace that technique? Why don't we just use BVA? Okay, so the problem over here can be that if we use three boundary values and let's say if the boundary value fails, in that case, we will not know if the boundary value failed or is that the entire partition failed. Because what we said for the equivalence partitioning, we will take one value from each group and then we will expect that entire group will behave in the same way. Over here, it might be the case that if the boundary value is failing, then the entire group is failing. But it can be the other case as well, that only the boundaries are failing, because sometimes if we have to find a defect, then the boundaries are the places where most defects are found. For example, the code which we just saw, that there was an issue with the code, and the error would be generated only when the boundary values, the extreme values, would be triggered. So that's why it's still useful to use both of them in combination, or wherever we need in terms of like what we are testing. So it is recommended to test partitions separately from boundaries, which means that choosing a partition value that are not boundary values. So let's say if we are combining, let's go to the next slide. So if we are combining equivalence partitioning and boundary value analysis, then take a value from the partition which is not the boundary value. So over here, what we are doing, we are combining equivalence partitioning and boundary value analysis. In this case, we are doing 3 boundary values and equivalence partitioning. And this will be giving us a very thorough coverage of our testing. Okay, but the problem over here is that we are using so many inputs that over here in this range, we are doing 19, 20, 64, 3 values from this group, 2 values from this group, and 2 values from this group. And maybe it looks like not a lot of testing, test data for this set of testing, but maybe we are testing a field or multiple fields where we have lots of equivalence classes, which means that if we go with this approach, we will have lots of inputs again. So maybe we are not utilizing our time in the best way. So if we are combining 3 value boundaries with equivalence partitioning, we are not getting any additional benefit from this. So the ideal approach will be to use 2 value with equivalence partitioning, and that would be highly effective. So over here, let's say that if we just discard these values, and if we are using just these, that would be sufficient. That will do the job, and that should be fine. Okay, so right. Okay, so now we can ensure that combining equivalence partitioning and boundary value analysis will give us a good coverage, but we still can't guarantee the 100% coverage. We can never guarantee 100% coverage. We can try definitely to do the maximum coverage. So the set of data which we assume that this field doesn't accept, let's say that right now we are doing the valid range and invalid range, but have you noticed that we can't see any special characters over here in this invalid range as well? Because why? We are assuming that if the requirement is this, then yes, we are testing invalid data as well, but we are assuming that this field will only accept numeric values. This will not accept any alphabets or any special character. So we are assuming it, but as per this test, we are not testing it. So let's say that we are covering all these values over here. We still can't guarantee that we are covering everything. So some of the time we have to think that what else we need to combine it with. So boundary value analysis and equivalence partitioning is not everything. There is much more in addition to it, which as a tester we need to take care of. But for this concept, I hope that it's all clear that how and when to apply boundary value analysis and equivalence partitioning. So there can be other factors as well for different projects, which can help us decide that which technique we have to use from these two, or maybe a combination of two. So let's say if we have to do a very, very thorough testing and we have ample of time, then we can combine 3 boundary value, and we can combine it with equivalence partitioning, and we can assure that we have thorough testing. And on the other side, let's say that if we have time constraints, and we can, in that case, we can just use equivalence partitioning, because we are just testing one value from each group. So still it is giving us a decent coverage. And the third scenario can be that we want to find the maximum defects, because maybe last time we had lots of defects on the extreme values. So this is what we want to target in our specific testing phase. So in that case, we can go for the boundary values only. So it depends that what kind of testing objective is, and based on that, a tester can decide that which kind of test technique they have to apply. Okay, so this is, with this one, we are done with the concepts, and now let's go through the questions. So first two questions I have added, which were also part of the assignments as well, and I saw a few of you were having issues with it, and these were not clear. So I was asked to clarify these in the session. So first of all, let's go through those, and then we can further do other questions as well. So the first one is, okay, I think we have a question. Okay, Sahana is asking, how can data be validated using boundary value? So Sahana, in that one, how can date be validated? So yeah, so Sahana, if we have a range of date, so let's say that if we have a range from, let's say, January to February, and in that, let's say if that's our valid range of January to February, so that would be our valid range, and then anything beyond January, sorry, not January to March, let's say, is a valid one. Anything beyond January and March would be our invalid range, and it will be in an order. So that's why we read that whenever we have to apply boundary values of technique, anything, any data that needs to be in a specific order or a sequence. Okay, so you said you got it. All right, thank you. Okay, coming back to this question. A system specification states that a particular field should accept alphabetical characters in either upper or lowercase. Which of the following test cases is from an invalid equivalence partitioning? So over here we have our valid range, which is uppercase and lowercase. And then we also specify our invalid, which can be a numeric one, which can be special characters, or it can be like more as well. Maybe a blank field would also be counted as an invalid one. But over here, I have just given these two examples. So the question is that which test cases is from invalid? So invalid, let's go through each of them. The first one is feeds, in which F is capital. So it's from our valid range. And the rest one is the lower case, which is again our valid range. So this is not from the invalid partition. So that would be incorrect. The second one is we have F from our capital F from our uppercase, valid. 3, 3, which is numeric, invalid. And then DS from lowercase. So we have these numeric values from our invalid equivalence partition, equivalence class. So this would be the correct option. But just to ensure that this is the right one, let's just go through the other ones as well. So this is all caps, all uppercase. So this will be valid scenario. So this will be incorrect option, because what we are looking for is invalid. And the last one is again a combination of upper and lowercase, no invalid character in it. So B would be the correct option. So I hope that people who were having issues with this question, it's now clear. If still there is any confusion, you can always ask me later as well. And the second question was this one. This was also part of the assignment. It says an automated air conditioner is programmed to turn its heating unit on when the temperature falls below 17 and turn its refrigeration unit on when the temperature exceeds 26°C. The air conditioner is designed to operate at temperature between -10°C and 40°C. So we have got our valid range. So first of all, we will write our valid range, which is -10°C to 40°C. Given the above specification, which of the following sets of values shows that the equivalence partition test design technique has been correctly used? Okay, so we have our valid range, and then based on this data, that heating unit is on when the temperature falls below 17. So this would be our subpartition. So we have to create subpartitions now. So then we will assume that -10 to 16 would be our one subpartition. Then 70, and it says that if it exceeds 26, then refrigeration unit will be on, which will be 27 to 40, because it says exceeds 26C, so 26 will not be included. And then the remaining one, 17 to 26, then it will be another range. So we have three subpartitions within our valid data. And then talking about invalid, anything which is 41C and above would be invalid. And on this side, anything which is below -10 would be invalid as well. And what we are looking for is that which set of values shows that the equivalence partition test design technique has been used correctly. So what was the rule of equivalence partition? That from each class, we have to use one value, only one value, but from each class. So we have to cover all the classes, which means we have to look for a set of data in which one value is from this range, one from this subpartition, this one, and this one. So we are looking for 1, 2, 3, 4, 5. So to save time on this kind of questions, as you can see that this is a lengthy question and you have to draw all this as well in the exam. And I think I didn't mention it before that during your exam, mostly it's online exam, is computer based, but you will be provided papers and pen as well, so that if you have to do anything like that, you have to draw something, you have to work out something, then you can do that on the paper as well. So you will have you will work on this, and that will also consume a lot of time. So you have to save your time wherever possible. So we know that we are looking for 5 options right now. So anything where we don't have 5 options, we don't even have to see those options. And this is very, very clear in this way. We only have this first option, which is A, which have 5. So luckily we don't have 5 anywhere else, 5 options. This is 4, these are 3, these are 6. So which means that A is clearly our answer. So we can just go ahead and mark it confidently, and that would be our right answer. But for the sake of doing it right now, let's just go through and confirm that whether this is correct or not. So over here, -11, it falls here, -1 here, 18 in this one, 27 in this subpartition, and 51 in this one. So we are using all the partitions as per the rule. If we talk about this one, let's see that where it goes wrong. So -11 is fine, -1 is fine, 12 is not fine, because in this range we are already taking -1, so we don't need to take another one. And over here, it's not using all the partitions, and the same issue over here as well. So A is the correct answer. So all the assignments which I received so far, this one was incorrect. So I hope that now it's clear. But still, if you have further question, you can always ask me later as well. Okay, so these were the 2 questions which were from the assignments and where most of the people were having issues. Now we will go ahead with our practice questions for today, and grab some piece of paper and pen and try to work out this, and then we can go through it together as well. I will I will say the question. The speedometer of a car uses 7 colors to show the speed. Each color covers a range of 20 kilometers with an operating minimum and maximum of 0 and 140. Which of the following values is least likely to have been identified when applying the boundary value test design technique? So go ahead, take your time, work out this one, and let me know that what's the right answer. And if it's not clear, let me know. If you're not able to attempt it, let me know. We can then do it together. Okay, I have got an answer from Denmark. Okay, I've got an answer from Madhuri as well. Okay, so Denmark has given the answer option C, and Madhuri has given the option D. So C is 7 and D is 121. Sahana is given C. Ankita has given the option C. Okay, so now we have got few of them. UV has given C as well. Okay, so let's go through the working out of this one. So I have done in this way. You can do whatever the way you want to do it. So we said the question said it has 7 colors. So we have divided into 7 colors, and then each color covers a range of 20 kilometer, which means the first color may be 0 to 20, then 21 to 40, until 121 to 140. And we have a minimum and maximum from 0 to 140. We know that. So that's how we have divided all the 7 colors, and covering each color is covering a range of 20 kilometer. The question is, which of the following value is least likely to be identified while applying the BVA test technique? Okay, so what we do in boundary value analysis, we look at the boundary. So over here, we have to look the boundaries of each partition, each group. So over here, the first option is -1. Okay, so -1 is one of the boundary value, and we're looking for the least one. So of course, that will not be the correct option. B is 0. Again, this is the boundary value. So this will not be the correct one. C is 7, which falls within this. So it can be a value for equivalence partitioning, but not for the boundary value analysis. So it can be, this is the right option because this is least likely to have been identified. And D is 121, which in this partition, it is the boundary value. So this is incorrect. Correct option is C, 7. Okay, so well done to everyone who got them correct. And I hope that it's clear. If there is any question on this one, let me know. Okay, let's go to the next one. Given the following specification, which of the following values for age are in the same equivalence partition? If you are less than 18, you are too young to be insured. Between 18 and 30 inclusive, you will receive a 20% discount. So go ahead and try to do this one. Okay, so Ankita has given me an answer. Okay, Denmark has also given us an answer. Okay, so Ankita has said C. Denmark has said C. Any more? Okay, Sahana has said D. And Madhuri has said D as well. Okay, so we have a split opinion between C and D. So let's then have a look at which one is the correct option. Okay, let's go through the question again. It says, if you are less than 18, you are too young to be insured, which means anything which is less than 18 is in our invalid group. Our valid is between 18 to 30 inclusive, which means it's including 18 and 30. And anything which is greater than 30, that would be our invalid as well. So 18 to 30 will also receive a 20% discount. So what is the question asking us? Given the following specification, which of the following values for age are in the same equivalence partition? So over here now we have made 3 equivalence classes based on the data given to us. And we are looking for an option in which all the values fall in one class. So let's go through this one. 17 is over here. 18 and 19 falls in this equivalence class. So they are not in the same equivalence class. Hence, this is the incorrect option. Second is 29. 29 falls in this valid range. 30 as well in this one, but 31 goes in this class. So we are having 2 values from this one from this. So this is also incorrect. The third one is 18, then 29 and 30, and all these 3 values falls in this class. So this is the correct option. C is the correct option. Let's see why D is not the correct option. 17 falls in this range. 29 in this one, 31 in this. So actually for option D, we are taking values from each different class. Okay, so what they have done, they have tricked us with this option. If we have to say that which is the correct equivalence partition, then this is the correct answer, right? But over here, they are saying that which of the following values are in the same equivalence partition. So we are talking about one group, only one group in which all values fall. So it's very, very important that we go through the questions at least twice to understand what's it asking us. Yeah, so Sahana has said I read the question wrong. Yes, Sahana, this is very it's very common, and it happens that we just go through the question and we just start attempting it, and sometimes this is the way they trick us in the exam. All right, so I hope this one is clear now. And the last question for the day is this one. Order numbers on a stock control system can range between 10,000 and 99999 inclusive. Which of the following inputs might be a result of designing tests for only valid classes and valid boundaries? So try to attempt this one, and then we will go through the answer. Okay, so Sahana has given us an answer, which is option C. Denmark has also given us option C. Ankita, C. And Jatin has said C as well. Okay, let's try to do this one. Okay, so this is quite simple because we have been given a valid range, which is between 10,000 and 99999. And what we have to do, first of all, I would suggest whenever you are attempting these kind of questions, first of all, draw your valid and invalid classes. And after that, once again, go through again what are you required to do with those ranges. So it says, which of the following inputs might be a result of designing tests for only valid equivalence classes and valid boundaries? So over here, we have to take care of both equivalence class and valid boundaries, and only valid, not the invalid ones. Okay, so the first one is 1000, which definitely is invalid. So this is out of the question. This is incorrect. Second one is 9999. Okay. And then we have 50,000. Okay. So 9999 is our boundary value, but it's our invalid boundary value because over here the boundaries would be 10,000 and -1 would be 999. So if we are just talking about possible boundary values, then this would be the correct option. But over here, because we are just saying valid boundary, so this will be incorrect. So this would be definitely not the right answer. The third one is 10,000, which is our boundary value. 50,000, yes, it would be a valid equivalence one because it falls in this range, so it can be our equivalence value. And this one would be our this boundary value. So this would be a good example of combining equivalence partitioning and boundary value analysis. So this is the right answer. Let's just have a look at the D1 as well. So this is the right one. This is the right boundary value as well, but this goes in the invalid range because it's beyond this one on the side. So this is incorrect as well. So C is the correct option. So well done, everyone. All of you got this question correct. All right, so with this one, then we come to the end of today's session. Is there any question from your side? So Sahana is saying it's clear. Thank you so much. You are most welcome, Sahana. So Denmark is saying good on my side. That's good. You're welcome, Denmark. Okay, that's good that it's clear because that was my intention, that this is a very, very important concept. It always comes in the exam in one way or another, and then we will really regret if this question would be wrong. So I hope that this concept is clear, and I think it was good to repeat this one just to ensure that everyone gets the purpose of these techniques and how and when to use it. But still, if you have any further questions, then do let me know. We will cover the rest of black box test techniques in our next session. So we will complete our black box test technique hopefully in the next session. So we have, I think, 3 more techniques left. So we'll do that. And if you have any other question, do let me know. I will upload the recording for today's session shortly, and I will also upload the slides as well. We already have the questions which few of you have attempted, few not. The ones who haven't attempted, please let me know. And once you have answered the question, I can review and get back to you on that. So till then, take good care of yourself, and I'll see you next week. Till then, bye.